Hi students, welcome to the next session. Previous session we finished up to 7.10 exercise. Now we'll continue next properties of definite integrals. In this first property, integral a to b f of x dx equal to integral a to b f of t dt. How to prove this one? Take the LHS. LHS equal to integral a to b f of x dx. Now, in the place of x, what is the real t? That's why I'll consider that x is equal to t. Whenever I change the variable, differentiate. Substitution, differentiating with respect to t or x derivative. X derivative is 1 into dx is equal to dt. Now changing limits also. What limits? Lower limit. Lower limit, what is the x value? A. That is a is equal to t. That means what? T is equal to u. Coming to upper limit. Upper limit x value, what is the b? That's why b is equal to t. From this, t value is b. Now that LHS becomes integral. Lower limit is a only for t variable, upper limit is b f of what is x value t and what is the dx. 1 dx is dx only is equal to what? dt. Now the function is not changes anything. Here as for same f of x dx, here also same f of t dt. The integral limits also not changing. That's why now we are replacing t by x. Or same we can take consideration wise. The value will be same. You can leave like that, both will be same you get. That's why you can leave this is the RHS required RHS value. Next, coming to second one. Now second one, integral a to b f of x dx equal to minus integral b to a f of x dx. Here what is the meaning of this property? If you interchange the integral limits, sign changes. In integral a to b, here lower limit is a, upper limit is b. But here lower limit is b, upper limit is a. The limits are interchanged. That's why sign change here. Okay? How to prove this one? Take the LHS. Integral a to b f of x dx. According to fundamental theorem of integral calculus, integral of small f of x is capital F of x. Don't take the same different. Now what the limits are there? A to b. Now substitute upper limit. Capital F of b minus capital F of a. I will take minus common from this. If you take minus common, both will changes. What will get first? F of a minus F of b. This can be expressed as integral. Here what is upper limit actually? Because we will substitute first upper limit and then lower limit. A to b, this is small f of x dx. Because integral of small f of x is capital F of x will get. By substituting here, what is the upper limit? You will change here. What upper limit here? A. What is the lower limit is b. That's why you will get minus integral b to a small f of x dx. That is the required RHS. Now these are the properties. Here first we can replace the dummy variable as simple called x. Replace it with t. If we interchange the limits, sign changes. Third property. Now this property is important. Actually in this chapter there are 6 marks question. Properties question. They will give property with attached problem. This third one, prove that integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx. Come where A less than C less than B. That means C is a value lying between A and B. That's what we need to prove that. For this there is an attached column also. Okay? But important property coming to prove, take LHS. What LHS is there? Integral A to B f of x dx. Now by fundamental theorem of integral calculus, integral of small f of x we can consider capital F of x, antiderivative, don't take plus c, a to b. Now substitute upper limit. What will get? Capital F of b minus capital F of a. This is LHS value. Take it as equation number 1. Now coming to RHS side. What RHS is there? Integral a to c f of x dx plus integral c to b f of x dx. Same by fundamental theorem of integral calculus. Fundamental theorem of integral calculus. Now in this, same integral small f of x will be what here? Capital F of x. The limits is from a to c plus here also capital F of x. The integral limits is from c to b. Now substitute upper limit. Upper limit is c, lower limit is a. Now what we will get here? Now that RHS is equal to capital F of c minus capital F of b plus, coming to second term, capital F of b minus capital F of c. Now plus f of c minus f of c gets cancelled. First term write positive value. RHS equal to f of b minus f of a. From 1 and 2, what we can decide? Both we got same only. LHS value is f of b minus f of a. RHS value also we got f of b minus f of a. Therefore, we can say that LHS is equal to RHS. Next, property number 4. This is also important for 6 marks, but property with attached problem will get. Prove that integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. This we need to prove it. Now consider LHS. What LHS is there? Integral a to b f of x dx. Here which one we need to substitute? In the place of x, what is there here? A plus b minus x. That value considered as t. Okay? Let a plus b minus x equal to t. From this find out t value, x value. Interchanging both, what you get here? A plus b minus t equal to x. Whenever applying substitution method, we need to differentiate both sides with respect to x. Or differentiating with respect to x. Now a derivative 0, b derivative 0, minus x derivative is dx is equal to dt. Send minus that side, what will you get? Dx is equal to minus dt. Now we are changing variable from x to t. That's why this a and b actually x limits, but we need to convert it in terms of t limits. That's why now I am changing limits. Left lower limit. Lower limit, what is x value is there here? A. Substitute here. That's why a plus b minus a is equal to t. A gets cancelled from this. T is equal to what here? B. Coming to upper limit. Upper limit, what is our upper limit is there here? For LHS, b. Substituting this. A plus b minus b equal to t. Here b gets cancelled. What is the upper limit of t is a. All values substituted in LHS. Now LHS equal to integral. What is the lower limit b? What is upper limit a? F of x. What is x value? X value is a plus b minus t. What is the dx is minus dt. Now take minus common. Minus integral b to a f of a plus b minus t into dt. According to second property, if we interchange the limits, sign changes. Now sign changes, one more minus will get minus or minus becomes plus. When you interchange the limits, what will get here? A to b f of a plus b minus t dt. And I am repeating, if we interchange the integral limits, sign gets changes. Already one minus is there. Minus or minus becomes plus. Now, the integral limits become same for LHS and RHS. Now we can replace t with x, dt with dx. Now what will get finally? Integral a to b f of a plus b minus x into dx. We got the same integral limits. That's why we are replacing t with x, dt with dx. And this is the required RHS. Coming to next, property number 5. This is also important. Property, there is one type of problem also. Prove that integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. It's an extension of this formula only, same one. Here in the place of a they given 0, in the place of b they given a. Same concept. Coming to proof, consider the LHS. What is LHS is there? LHS equal to integral 0 to a f of x dx. Now which one we need to consider t is important. In the place of x, right side what is there here? A minus x. That is a clear hint is there. Which one we need to consider as t? That is a minus x is t here. Let a minus x equal to t. From this find out x value. So what will get? A minus t equal to x. Interchanging both. Whenever you substitution method apply, we need to differentiate immediately. Now differentiate with respect to x. A derivative 0 minus x derivative plus minus dx is equal to dt. From this, dx is equal to minus dt. Now dx changed into dt, okay? Now but we need to change the limits also because it's actually x limits. We need to convert in terms of t limits. First the lower limit. So lower limit. Here what is the lower limit is there? 0. Substitute here we get t value. A minus 0 equal to t. From this t equal to a. Next upper limit. Upper limit what is there here? A. Substitute in this. A minus a equal to t. From this a gets cancelled. T equal to 0. Now the LHS becomes, substitute is all values in this LHS. Integral, what is the lower limit? A. What is the upper limit? 0. F of x. What is x value? A minus t. What is the dx value? Minus dt. Now take minus common. Integral a to 0 f of a minus t dt. Now again, I am interchanging these limits. When you interchange the limits, sign changes. The minus or minus becomes plus. So integral 0 to a f of a minus t dt. Here the limits become same here for LHS and RHS values. That's why now replacing t with x and dt with dx. Integral 0 to a f of a minus x into dx. This is the required RHS. So next, sixth property is also important. It's also 6 marks property only. Property with attached problem. Prove that integral 0 to 2a f of x dx equal to, have two conditions. 2 into integral 0 to a f of x dx if f of 2a minus x equal to f of x. The value of integral is 0 if f of 2a minus x equal to minus f of x. At these conditions, this integral value becomes 2 times of integral 0 to a f of x dx. At this condition, the integral value becomes 0. We need to prove that. Now, coming to proof, take that LHS. What LHS is there? Integral 0 to 2a f of x dx. Which is, we need to consider t, but before this we need to split this one. How to split here? 0 to 2a. Generally, if you take number 0 to 2, exact integral value what will get? 1 in between that. Remaining our decimals will get 0 to 2 integral value is only 1 in between 0 to 2. Like that, 0 to 2a, another integral value is a. We are splitting this interval into 2 parts. 0 to a1 and a to 2a. 0 to a f of x dx plus a to 2a f of x dx. These are given LHS. Take it as equation number 1. The first one exactly as per limits is the 0 to a f of x dx. But coming to second integral, a to 2a f of x dx not in the same limits. It is totally a to 2a different limits are there. We need to simplify this second integral. Consider value separately. Predict I. Integral a to 2a f of x dx. How to simplify this? For that, in case there clearly here, we need to apply substitution method. Which is t we need to take here. 2a minus x is the t. Let 2a minus x equal to t. From this interchanging means you get x value 2a minus t equal to x. Now take a substitution method, that's why differentiate this. Differentiating with respect to x. 2a derivative 0 minus dx equal to dt. Send the minus right side. We'll get dx equal to minus dt. Now we need to change the limits also. Here lower limit is a, upper limit is 2a. These limits are x limits. Now we are converting in terms of variable t. That's why limits also we need to convert in terms of t variables. The first lower limit. What's the lower limit is there here? A. Substitute here. 2a minus a equal to t. From this 2a minus a, what will get? A. That's why t value is a. Next, upper limit 2a minus, what is the upper limit is there here? 2a. That's why 2a minus 2a equal to t. 2a 2a gets cancelled. From this t value is 0. This value substitute in I, integral term. I equal to integral. What is the lower limit? A. What is the upper limit? 0. F of x. In the place of x, what we need to substitute? 2a minus t. And what is the dx value is? Minus dt. Now take minus common from this. Minus integral a to 0 f of 2a minus t into dt. Interchanging the limits means sign changes. It will becomes plus integral 0 to a f of 2a minus t into dt. Now limits become same, 0 to a only as per LHS value. That's why, as per required form, 0 to a. That's why t replaced with x and dt replaced with dx. integral 0 to a f of 2a minus x into dx. Now this is I, the value in first equation, second value is again substitute in equation 1. Now the LHS becomes, first value what is the here, integral 0 to a f of x dx plus 0 to a f of x dx plus second value is only considered as I, that value we got 0 to a f of 2a minus x into dx. This is a simplified value we got now. Now we need to apply these conditions. What is the first case is there? F of 2a minus x becomes f of x. We need to get this value. F of 2a minus x is minus f of x. We need to get 0 is the value. Okay? Now, case number 1. What if f of 2a minus x equal to f of x? This value substituted in LHS. In the place of f of 2a minus x, we need to substitute what here? F of x. Now LHS becomes integral 0 to a f of x dx plus integral 0 to a f of 2a minus x is what here? F of x. Both are same only now. Both are same values. Put them side by side. 2 times of integral 0 to a f of x dx. Now next second condition. Case number 2. Or condition number 2. What is the condition number 2? If f of 2a minus x is minus f of x. So of course same value is LHS. LHS equal to integral 0 to a f of x dx. This f of 2a minus becomes minus f of x. Plus into minus is minus integral 0 to a f of x dx. Now both having opposite sign and same value, that's why cancel this 0. This is the property of property number 6. Two conditions, integral 0 to 2a f of x dx. One is 2 times of integral 0 to a f of x dx. Under value is 0. So coming to next property is the last property. This is also important for 6 marks with another problem. Integral minus a to a f of x dx equal to 2 times of integral 0 to a f of x dx if f is even function. This condition if they are not given, we need to write. This is a even function condition. F of minus x equal to f of x. 0 will get if f is a odd function. What is the odd function condition? F of minus x equal to minus f of x. Coming to proof. Now consider the LHS. What is LHS is there? Integral minus a to a f of x dx. Now this one we need to split into 2 parts. Minus a to a. For negative and positive, what is another integral value in between that? It's clearly 0. If you take minus 1 and plus 1, in between those two values, integral value clearly 0 only. That's why I am splitting this minus a to a integral into 2 parts. Minus a to 0 and 0 to a. Now LHS equal to, first I am taking from where to where? Minus a to 0 f of x dx plus 0 to a f of x dx. It's considered as equation number 1. In this, second value clearly as for RHS is there, integral 0 to a f of x dx. But observing first value, it is a limits totally differently is there, minus a to 0 f of x dx. But we need in the form of 0 to a. That's why we need to simplify this value. That's why let consider there is I minus a to 0 f of x dx. Separately take. Consider I is this value. But how to simplify this? Which one we need to consider as t? Because clearly there is the hint, that is minus x is the t. Let minus x equal to t. Send minus right side, what we get? X is equal to minus t. I am changing variable x in terms of t. That's the differentiate of this one. Differentiating with respect to x. minus dx is equal to dt. Side minus right side, dx is equal to minus dt. Now we need to change the limits also. First lower limit. Lower limit, what is the x value is there here? Minus a. Here substitute this. We need to get t. Minus of minus a equal to t. That is minus of minus a is plus a. That is t equal to a. Upper limit. What is the upper limit is there here? 0. 0 substitute minus 0 also becomes 0 only. From this, t equal to 0. These values substitute in I. I equal to integral. What is the lower limit? A. Upper limit 0. F of x. What is x value here? Minus t. Dx value is minus dt. Take minus common. Minus integral a to 0. F of minus t dt. By ever changing integral limits, sign changes. This minus becomes plus. The limits will become 0 to a. F of minus t into dt. As for RHS, we got the integral limits 0 to a. That's why substitute the t symbol with x, dt with dx. Now we got according to the integral limits. Now we need to substitute this value in equation 1. From equation that is LHS equal to first value only we change. First value we got what here? Integral 0 to a f of minus x dx plus second value remains same. Integral 0 to a f of x dx. We got a simplified form. Now we need to apply this condition. We need to get required RHS. Now first condition, case number 1. If f is even, even means what? F of minus x equal to f of x. In the place of f of minus x, substitute f of x. LHS equal to integral 0 to a f of x dx. Second value no changes. Integral 0 to a f of x dx. Now both are same only, having same sign. That's why this is 2 times of integral 0 to a f of x dx. Coming to second condition, case number 2. What case number 2 is there? F of minus x. F is an odd function. Now odd function f of minus x equal to minus f of x. Substitute here in LHS part. LHS equal to this is becomes minus f of x. So minus common. Minus integral 0 to a f of x dx plus integral 0 to a f of x dx. Both same values but having opposite sign. Both gets cancelled. What's the value? 0 we got. LHS we got 2 conditions. At f of minus x equal to f of x, we got first value. At f of minus x equal to minus f of x, we got 0. We finished up to all properties, 7 properties. In that property number 3, 4, 5, 6, 7 are important for 6 marks. And one more property is just a formula only. Integral a to a f of x dx. When the integral limits both are same is there, then the integral value becomes 0. How means simple. Integral of small f of x is capital F of x. Upper limit minus lower limit. F of a minus f of a will get. The value becomes clearly 0. This is a property, remember. Now we will start problems based on these properties. Now example 1. Evaluate integral minus 1 to 1 mod of x cube minus x dx. This one based on third property, splitting interval. A to b splitting into a to c f of x dx, c to b f of x dx. Now, but in between minus 2, minus 1 to 2, which values we need to consider, we don't know. How to get means, if you take this x cube minus x function is become 0. At where it will become 0, that values we need to consider in between minus 1 to 2. If you take x is common from this, x square minus 1 equal to 0. x is equal to 0 and x square minus 1 equal to 0, x square equal to 1, x is equal to plus or minus 1. By substituting function is equal to 0, you will get another integral values. That's why in this we are taking the integral limits from minus 1 to 2, one value is 0, another one is 1. Two set of values is there in between minus 1 to 2. At these values, this function value becomes 0. Now, but we need to identify sign because it is a modulus. Modulus value sign either minus or plus based on the integral limits. Okay? Now, first we are splitting into minus 1 to 0. Minus 1 to 0, take any one value, substitute in this function. For example, minus 1 to 0, I take x is equal to minus 1 by 2. Sign we need to identify because to remove modulus, we need to remove modulus. We need to check the sign, plus or minus. Now x is minus 1 by 2, so put here minus 1 by 2 whole cube, minus or minus plus 1 by 2, minus 1 by 8 plus 1 by 2. Which is the greatest value? 1 by 2 is the greatest value, positive. If we take LCM also, LCM is 8, minus 1, 4 times we will multiply. So 4 minus 1 is clearly 3 by 8. That's why in this interval, sign is positive, plus. Next, 0 to 1 take. 0 to 1 can I take 1 by 2? 0.5. Substitute sign, what will get here? 1 by 2 whole cube, that is 1 by 8, minus 1 by 2. This is clearly minus, negative is the greatest value. That's why this is clearly negative value. This is minus. 1 to 2. 1 to 2 can I take 3 by 2? Because 1.5. Now 1.5 3 by 2 substitute, what will you get? 3 by 2 whole cube minus 3 by 2. Now to remove modulus, we need to identify the sign in the interval. 3 cube 27 by 8 minus 3 by 2. LCM how much? 8. 27 minus 4 times multiple, 4 3 is 12. 27 minus 12 clear 15 by 8. Positive only, that's why here also positive only. Now, because directly we can't integrate modulus function, to remove modulus, we need to identify the sign in that interval. Clearly minus 1 to 0, this is plus only, that's why by removing modulus, we get only bracket x cube minus x dx. 0 to 1, modulus value becomes negative. So here 0 to 1 minus of x cube minus x dx. Next 1 to 2, this is clearly positive. X cube minus x dx. Before integrating, first multiply this minus inside. Minus 1 to 0, x cube minus x means power 1 dx plus integral 0 to 1 x minus x cube dx plus 1 to 2 x cube minus x dx. Here x means power 1 only, power 1. Now we can take this function. Integral of x cube is clearly x power n formula. X power n plus 1 by n plus 1, that is x power 4 by 4. Here x power 1, that is x power 1 plus 1 is 2 by 2. The limits is minus 1 to 0 plus x power 1 integration is x square by 2. X cube integration is x power 4 by 4. Limits is from 0 to 1. Next, x cube integration x power 4 by 4 minus x square by 2. Limits is 1 to 2. Now substitute for every value, upper limit and lower limit. Upper limit substitute here 0 by 4, 0 square by 4, 0 only. So 0 minus 0. Minus of lower limit. Minus 1 whole power 4 is 1 by 4. Minus 1 whole square is 1 by 2. Plus here upper limit 1 by 2 minus 1 by 4. Minus lower limit, what is that? 0 by 2, 0 by 4 is clearly 0. Plus next here upper limit 2 power 4, 16 by 4 minus 2 square, that is 4 by 2 minus What is the lower limit? 1. 1 power 4 is 1 by 4 minus 1 by 2. Let us simplify this. This is clearly 0 limit. Minus 1 by 4 plus 1 by 2 plus 1 by 2 minus 1 by 4. 16 by 4, that is 4, minus 4 by that is 2. Multiply minus inside, minus 1 by 4 plus 1 by 2. How many 1 by 2 values are there? 1 by 2, 1 by 2, 1 by 2. That is total 3 into 1 by 2 is 3 by 2. 1 by 4 values into how many are there? 1, 2, 3. This is also minus 3 by 4. Here remaining what is there? 4 minus 2, that is plus 2. Overall, what is LCM? 4. 4 is the LCM. Take 4 is the LCM. 2 times will multiply. 3 2s are 6. Here 1 time. Here 4 times will multiply 8. So here 6 minus 3, 3. 3 plus 8, that is clearly 11 by 4 is the answer for this question. Next, second question. Evaluate integral minus pi by 4 to pi by 4 sine square x dx. Now we need to simplify this function. So directly we found the integral of sine square, we don't have any formula, but we have formula sine square theta in terms of cos. It is 1 minus cos 2 theta by 2. We are using this formula. Okay? Now, integral minus pi by 4 to pi by 4, 1 minus cos 2x by 2 into dx. Now, integral take 1 by 2 common, constant. Integral minus pi by 4 to pi by 4, 1 minus cos 2x dx. Now, we can integrate 1 by 2 into integral of 1 dx, clearly x, integral of cos sine 2x by inner function derivative by 2, from minus pi by 4 to pi by 4. Now substitute the upper limit and lower limit. Upper limit what? Pi by 4 minus sine 2 into pi by 4. It will becomes pi by 2 by 2 minus lower limit minus pi by 4 minus sine 2 into minus pi by 4. 2 ones are 2 2s are. It will becomes minus pi by 2 by 2. Simplification we will do here. 1 by 2 into pi by 4 sine pi by 2 sine 90. Sine 90 is what? 1. That is minus 1 by 2. Multiply minus inside, minus or minus, plus pi by 4. Minus into minus, plus sine of minus 90, minus sine 90. Sine 90 value is what? Clearly minus 1 by 2. So 1 by 2 into pi by 4 plus pi by 4. 45 plus 45, 90. 90 means what? Clearly pi by 2. Here minus 1 by 2 plus, sorry, minus 1 by 2 minus 1 by 2, because plus into minus is minus only. Now minus 1 by 2 minus 1 by 2 becomes minus 1. So from this 1 by 2 into pi by 2 minus 1 will get. If you want to simplify, you can multiply 1 by 2 inside. What will you get here? Pi by 4 minus 1 by 2 is the required answer. Next, third one. Evaluate integral 0 to pi x sin x by 1 plus cos square x into dx. Now here directly we can't apply substitution method, any other method also, because here only sin is there. We will consider cos x is t. Derivative of cos is minus sin x dx is, you will get minus dt. But here x also involved. That's why we can't apply substitution method in this case. Now first, consider the given value is pi, integral 0 to pi x sin x by 1 plus cos square x dx. We know our property integral 0 to a f of x dx. We can write integral 0 to a f of a minus x dx. F of x we can write f of a minus x. That means in the place of x we need to write a minus x. And what is the a? Pi minus x. Now I equal to integral 0 to pi. In the place of x I am writing a minus x, that is pi minus x. Sine of pi minus x by 1 plus cos square of pi minus x into dx. Integral 0 to pi minus x. Sine pi means 180. Sine 180 minus the second quadrant. Sine is positive, function remains same. Sine x only by 1 plus cos 180 minus the is minus cos theta, but we have whole square, that's why it becomes plus only cos square x dx. Now multiply inside with sin x with denominator. Integral 0 to pi sin x into dx by 1 plus cos square x minus integral 0 to pi x sin x dx by what is the denominator? 1 plus cos square x. This is clearly the value of which one? I. The integral term what you considered already. So replace I symbol in this. I equal to integral 0 to pi sin x by 1 plus cos square x dx minus I. Take this minus I this side, it becomes plus 2I equal to integral 0 to pi, take pi common, pi into integral 0 to pi sin x by 1 plus cos square x into dx. Now to simplify this, now we can apply substitution method. Reason, if you take cos x is t, derivative of cos is in terms of will get sine. Sine will get negative, you can take right side of column. That's why let consider cos x equal to t. Differentiate with respect to x. Cos x derivative minus sin x into dx equal to dt. Send this minus right side. Sin x dx equal to minus dt. Now we need to change the limits also. What is the lower limit and upper limit? Lower limit, what is there here? 0. Substitute here. Cos 0 equal to t. From these, cos 0 value how much? 1. Upper limit. What is upper limit? Pi. Substitute here. To get t limits, cos pi equal to t. Cos 180 is minus 1. T is equal to minus 1. Substitute all values in this term. 2I equal to pi into integral. Lower limit is 1. Upper limit is minus 1. Sin x dx becomes minus dt by 1 plus t square minus, we take common, minus pi into integral 1 to minus 1 by 1 plus t square into dt. This clearly in which form? Integral 1 by 1 plus x square. Formula what? Tan inverse x. As for that, 2I equal to minus pi into, this clearly formula for tan inverse t. The limit is from 1 to minus 1. Now substitute upper limit. Tan inverse of minus 1 minus tan inverse of 1 minus pi. Tan inverse of minus 1 is minus pi by 4 minus tan inverse of 1. Tan 1 and tan 45. 45 means pi by 4. Here left side 2I is there, minus pi, minus 45 minus 45. Minus 90 will get minus 2 pi by 4. 2 ones are 2 twos are. So 2I equal to minus into minus plus pi into pi is pi square by 2. Take the 2 right side, it becomes a denominator. I is equal to 1 will get here. Pi square by 4 is the value of integral term. So example 4. This is important for 1 mark attached problem. Evaluate integral minus 1 to 1 sine power 5x into cos power 4x dx. Now this is a based on property integral minus a to a f of x dx. If the function is even, we can write 2 times of integral 0 to a f of x dx. If function is odd, the value of integral becomes 0. That concept we are applying in this case. Now this given function is even or odd, we don't know. We need to find out. Select the function f of x. Consider sine power 5x into cos power 4x. How to check even or odd? Substitute x with minus x. Or replace x with minus x. Sine power 5 minus x. Cos power 4 minus x. Sine of minus theta is minus sine theta, that's why minus sine x whole power 5. Cos of minus theta is cos theta only, that is cos x whole power 4. But negative power odd number will get negative only. Minus sin x whole power 5 becomes sin power 5x. Cos x whole power 4 becomes cos power 4x. Here what? F of minus x equal to minus. This is which one? F of x. This is clearly condition for which one? F is odd function. For odd function, according to the property, the value of integral becomes 0. So integral minus 1 to 1 sin power 5x into cos power 4x dx value is 0. Reason? F is an odd function. Next one. Fifth one. This is also important for 3 marks. Attached problem for property. Let which property attached problem? Evaluate integral 0 to pi by 2 sin power 4x by sin power 4x plus cos power 4x dx. Now first given value assume as let I equal to integral 0 to pi by 2 sin power 4x by sin power 4x plus cos power 4x dx. Consider as equation number 1. Now this is a based on property integral 0 to a f of x dx. Integral 0 to a f of x dx. What is the property? Integral 0 to a f of a minus x dx. For this property, there will be attached column. Property proof with attached column. I equal to here what? In the place of x, we need to write a minus x. Wherever x is involved in the function. Integral 0 to pi by 2 sin power 4 pi by 2 minus x by sin power 4 pi by 2 minus x plus cos power 4 pi by 2 minus x dx. I equal to integral 0 to pi by 2 sin 90 minus theta, clearly cos theta. So it will become cos power 4x by cos power 4x plus sin power 4x dx. Now this is the after applying property, this is the value we got. Now equation 1 is before applying property. For both integral limits is same, dx is same, denominator also same. What happened? Sin power 4 plus cos power 4. Cos power 4 plus sin power 4. Both are same only. That's why I am adding this 1 and 2. Adding 1 and 2 means what? Left side I plus I 2y. 0 to pi by 2. What first value here? Sine power 4x by sine power 4x plus cos power 4x dx plus 0 to pi by 2 cos power 4x by cos power 4x plus sine power 4x dx. Denominator both are same only now. You take LCM. By taking LCM, what will get here? 2i equal to integral limits are also same. It also common. Denominator also same. What denominator? Sine power 4x plus cos power 4x. We can add in numerators. What is the numerator here? Sine power 4x, here cos power 4x. Sine power 4x plus cos power 4x dx. Both are same, gets cancelled. Integral 0 to pi by 2, 1 dx. Now 2i equal to integral of 1 dx is what? X. Don't take plus sigma. 0 to pi by 2 is the limits. Now take upper limit. 2i equal to upper limit is what? Pi by 2. Lower limit is 0. Now divide with 2. What will be the answer? Pi by 4 is the answer for this question.